A single comma. That's all it was. One tiny punctuation mark in millions of lines of code. But this wasn't just any comma. It was the most expensive typo in history, costing hundreds of millions of dollars and nearly ending humanity's dreams of space exploration. This is the story of how one programmer's simple mistake brought down a multi-million-dollar spacecraft, destroyed years of work, and taught the world a harsh lesson about the importance of software testing. The year was 1962, and the space race was at its peak. The Soviet Union had already put a man in space, and America was desperate to catch up. Every mission was crucial, every failure a national embarrassment. At NASA's Jet Propulsion Laboratory, a team of the world's brightest minds was working on the Mariner 1 mission, an ambitious attempt to send an unmanned probe to Venus, humanity's first interplanetary voyage. The Mariner 1 spacecraft was a marvel of engineering, packed with scientific instruments, cameras, and communication equipment. But all of this sophisticated hardware was controlled by something far more fragile: software. In 1962, computer programming was still in its infancy. There were no modern development tools, no debugging software, no safety nets. Programmers wrote code by hand, punched it into cards, and hoped for the best. The guidance system for Mariner 1 was one of the most complex software programs ever written at the time. It had to navigate through space, communicate with Earth, and execute scientific observations, all automatically. The programming team worked tirelessly for months, writing thousands of lines of code in assembly language. Every instruction had to be perfect. There would be no way to fix bugs once the spacecraft launched. On July 22, 1962, everything was ready. The Atlas rocket stood on the launch pad, Mariner 1 perched on top, ready to make history. Millions of dollars and years of work came down to this moment. The countdown began. 10, 9, 8. Mission Control held its breath as the most ambitious space mission in history prepared to leave Earth. Nobody knew that disaster was already written into the code. Liftoff! The Atlas rocket roared to life, carrying Mariner 1 toward the stars. For the first few minutes, everything seemed perfect. The rocket was on course, the spacecraft was responding normally. But then something went wrong. The rocket began to veer off course, wobbling erratically as it climbed toward space. In Mission Control, warning lights began flashing as controllers watched in horror. The range safety officer faced an impossible choice. The rocket was heading toward populated areas, potentially threatening thousands of lives. There was only one option: destroy the spacecraft. At 293 seconds after launch, the destruct command was sent. Mariner 1 exploded in a brilliant fireball, scattering debris over the Atlantic Ocean. Years of work and millions of dollars vanished in an instant. The immediate cause was clear: a failure in the guidance system. But what had caused the guidance system to fail? The investigation that followed would uncover one of the most shocking discoveries in computing history. Teams of engineers pored over every line of code, every circuit diagram, every component. They were looking for a catastrophic failure, a major design flaw. What they found was far more disturbing. The problem wasn't a major system failure. It wasn't a hardware malfunction or a design error. It was a single character in the guidance software, a hyphen that should have been a comma. In the original mathematical formula, the code was supposed to read r.bar n with a comma, but someone had typed a hyphen instead. This single character completely changed how the guidance system interpreted velocity data. The hyphen caused the guidance computer to receive incorrect velocity readings. Instead of following the planned trajectory to Venus, the spacecraft's navigation system was feeding it garbage data. As the rocket climbed higher, the guidance system became increasingly confused. It was trying to correct for errors that didn't exist while ignoring the real trajectory problems that were developing. The error compounded with each passing second. What started as a tiny discrepancy in the code became a massive deviation in the rocket's path. The spacecraft was essentially flying blind. The most expensive typo in history cost NASA $18.5 million, equivalent to over $150 million today. But the real cost was measured in lost opportunities and damaged morale. The Mariner 1 disaster became a cautionary tale about the importance of software testing. It showed that in the digital age, the smallest errors could have enormous consequences. But NASA didn't give up. The space agency immediately began developing new testing procedures, code review processes, and quality assurance methods. The lessons learned would reshape software development forever. Just 5 weeks later, NASA launched Mariner 2 with corrected software. This time, the mission was a complete success, becoming the first spacecraft to successfully fly by another planet. The Mariner 1 incident established the importance of rigorous software testing. It proved that computer programs controlling critical systems needed multiple layers of verification and validation. The hyphen comma error became legendary in programming circles. It was cited in computer science textbooks and used to teach students about the importance of attention to detail in coding. But Mariner 1 wasn't the only victim of punctuation problems. Throughout computing history, similar tiny errors have caused massive failures, from crashed planes to financial disasters. The incident highlighted a fundamental truth about software. Complexity creates vulnerability. The more sophisticated our systems become, the more ways they can fail catastrophically. Modern spacecraft software now undergoes years of testing before launch. Every line of code is reviewed multiple times, and extensive simulations verify system behavior under all possible conditions. The tools we use today to prevent software errors, code reviews, automated testing, version control, all exist partly because of lessons learned from disasters like Mariner 1. But even with all our modern safeguards, software bugs still cause billions of dollars in damage every year. The Mariner 1 incident reminds us that perfection in programming is an ongoing challenge. The story of Mariner 1 also illustrates the human side of programming. Behind every line of code is a person who can make mistakes, have bad days, or simply overlook a small detail. The programmer who made the hyphen comma error was likely a dedicated professional who made a simple mistake that anyone could have made. In the aftermath of the disaster, NASA instituted buddy programming, requiring 2 programmers to review each other's code. This simple practice could have prevented the entire incident. The Mariner 1 incident became a turning point in software engineering. It marked the beginning of formal software quality assurance and the recognition that programming was a critical engineering discipline. Today's mission-critical software undergoes extensive formal verification. Mathematical proofs are used to verify that code will behave correctly under all possible conditions. The lessons from Mariner 1 extend far beyond space exploration. Banking systems, medical devices, and autonomous vehicles all rely on software that must be absolutely reliable. The hyphen that destroyed Mariner 1 serves as a permanent reminder that in the digital age, attention to detail isn't just important, it's critical to success and sometimes survival. Modern integrated development environments now include spell checkers, syntax highlighting, and automatic error detection. These tools help prevent the kinds of simple typos that doomed Mariner 1, but technology alone isn't enough. The human element remains crucial. Every programmer carries the responsibility of being the last line of defense against catastrophic errors. The Mariner 1 incident taught us that software errors don't just cause inconvenience, they can destroy missions, waste resources, and dash the dreams of thousands of people. Yet from this disaster came innovation. The quality assurance practices developed after Mariner 1 helped ensure the success of the Apollo moon landings and countless other space missions. The story of Mariner 1 reminds us that progress often comes through failure. Each mistake teaches us something new about building better, more reliable systems. Today, as we develop AI, autonomous systems, and other critical software, the lessons from that single hyphen in 1962 remain more relevant than ever. The most expensive typo in history cost far more than money. It cost time, opportunity, and confidence. But it also gave us invaluable lessons about the importance of software quality. Every programmer today owes a debt to the anonymous engineer who made that fateful typo. Their mistake became everyone's lesson, and their failure became the foundation for better practices. If this story amazed you, don't forget to subscribe and hit that notification bell for more incredible tech tales. Like this video if you learned something new, and share it with anyone who appreciates the hidden stories behind technology. What other software disasters would you like to hear about? Let me know in the comments below.